Hi, everyone. Welcome to this session at the Climate Adaptation Research Symposium on breaking rules during record-breaking heat. We are delighted to have three excellent speakers. My name is Devrat Garg. I'm an assistant professor of economics here at the School of Global Policy and Strategy, and I work on a number of climate adaptation issues. Today, we're joined by Patrick Behrer, Nick Sanders, and Dylan Brewer, who will be presenting their work on how heat has psychological effects and how we need to think about these in climate adaptation. I do want to thank our event collaborators that are listed on the slide here. They have been very gracious to provide support for this symposium so that we can all get here and discuss the important topics on climate adaptation. So without further ado, I'm going to hand over the floor to Patrick, who will be talking about heat, crime, and punishment.
Thank you, Devrat. Thanks for the introduction. As he said, I'm Patrick Behrer. I'm an economist at the World Bank. Until quite recently, I was a postdoc at Stanford University at the Center on Food Security and the Environment. And this is work that's joint with Valentin Bolotny, who's also at Stanford at the Hoover Institution. And sorry, let me see if the slides will advance. The question that we're going to examine, or that we examine in the paper that I'd like to talk to you about today, is how a changing climate is going to affect criminal activity. I'm showing you here a figure from a recent New York Times piece about how shooting victims increase on hotter days in cities across the United States. So you see a large increase in cities like Philadelphia and Detroit that are cooler than average, but you still see a substantial increase in places like Atlanta and New Orleans that are hotter than average. And this builds on a broad literature in economics and psychology that we're also going to build on that shows negative impacts of heat on criminal activity, as well as negative impacts on emotional state and psychological control, and negative impacts for cognition and cognitive ability as well. Despite this broad literature, I think it remains a little bit unresolved what the precise mechanism is that links heat and criminal activity. Why is it that we see shootings increase on hotter days or see other types of crimes increase on hotter days? And so we're going to focus on that today. And we're going to advance an argument that I think was quite succinctly summarized by Dostoevsky 150 years ago when he wrote, "Reason is the slave of passion in Crime and Punishment." There are two common mechanisms that are suggested to link heat and criminal activity. One is a rational criminal model in the mold of Behrer that suggests that crimes increase because criminals respond to potentially reduced police effort, for example, when it's hotter out, by increasing their criminal action. Or they might respond to changes in the relative payoffs of crime and non-criminal activities. I'm going to focus instead today on the psychological explanation that I alluded to before. Heat, lots of work in psychology has shown that heat changes people's emotional state. It reduces their psychological control, and in particular, it increases aggression. And so we're going to argue that the increase in crime that we see is driven primarily by this increase in aggression. And specifically, we're going to see an increase in violent crime as a result of exposure to heat. In other work, Valentin and I also examine how this rational criminal model, by exploring how flooding and other forms of weather-related destruction might affect crime. I'm happy to talk about that in the question and answer session later. But for the rest of the presentation, just keep this psychological mechanism in mind. And once you start thinking about a psychological mechanism for the impact of heat on criminal activity, you realize that criminals or criminal defendants are not the only people involved in the judicial process that might be impacted by heat. If there's a psychological channel through which heat is changing behavior, it may also be changing the behavior of police officers, of prosecutors, and of judges. And indeed, other work has examined the impact of heat on police officers and judges. I'm not aware of any work that's examined the impact of heat on prosecutors, so we'll add that to the literature here. But we're also going to take advantage of what I think is a unique data set that allows us to look at the impact of heat on all of these individuals in a unified setting. Much of the existing work has looked separately at heat on criminal defendants or heat on judges or heat on police officers across different settings or different data sets. Our data allows us to look at all of these individuals and the events throughout the course of a criminal defendant's experience with the judicial system in a unified framework. And that data is going to come from the Texas Department of Public Safety. So it's every arrest in Texas from 2010 to 2017. That gives us about 3 million arrests. It also gives us the demographics on the arrested individuals, importantly, including their home address. The arrest charge, so that is the charge that the police officers filed at the time of the arrest, and their trajectory through the criminal justice system. And what I mean when I say trajectory through the criminal justice system is we know when the prosecutors made decisions about their cases, the specific date. We also know what those decisions were. For example, whether they changed the arresting charge or added additional charges to the arresting charge. We know the date that the criminal defendant faced the judge, and we know what the judge's decisions were in that trial. We also know for convicted defendants that were sentenced to jail time or sentenced to pay fines, what the length of their jail time was and what the fines that they were sentenced to pay were. We'll combine that with reported crimes, or all crimes that were reported to the Houston Police Department from 2010 to 2017. This is the 5th largest police department in the country, and its jurisdiction covers several million people. We're going to use that to examine how police activity might be changing in response to higher temperature. We'll combine all of this with the now standard PRISM climate data on maximum and minimum temperature, precipitation, and we'll use dew point and vapor pressure deficit as proxies for humidity. And then we'll also use the 5-year American Community Survey data from the US Census matched with the addresses of the arrested individuals to get information at the block group level about the median income and the median housing age in the neighborhood in which the arrested individuals lived. We'll estimate the standard Poisson fixed effects model, where our outcome is going to be the conditional count of crimes in a given county on a given day. We'll include day of week fixed effects, month fixed effects, and year fixed effects, as well as a county fixed effect. And what we're going to be interested in is understanding the percentage change in crimes on a given day where the maximum temperature is in any one of a number of temperature bins, for example, 90 to 95 degrees, relative to the 60 to 65 degree bin. So I'll go through our primary results, and then I'm going to talk a little bit about what we do to account for future climate change and what role we think that adaptation can play in mitigating the future impacts of increased heat on criminal activity. I think the headline result is that, consistent with a lot of the existing literature, we see exposure to heat increases crime. Days above 90 degrees, we see increases in crime of around 5%. That increase is driven almost entirely, sorry, can you guys see the figure on this slide or not? Interesting. It looks like this slide's missing its figure for some reason. You have to take my word for it. The increase in violent crime, the increase is driven almost entirely by violent crime. So on days above 90 degrees, we see increases in violent crime between 10 and 15%. You can compare that to nonviolent crime, which we don't see any meaningful change in nonviolent crime from at temperatures above 70 degrees. We do, however, see similar declines in violent and nonviolent crime at temperatures below 60 degrees. So we think that this is pretty strong evidence for the psychological mechanism that I was alluding to above. If you expect the way that heat is changing criminal activity is by increasing aggression, you would expect that to manifest in precisely the kinds of crimes we see increase. So assault, aggravated assault, homicide, and manslaughter. Whereas we don't see any increase in non-aggressive crimes like larceny, burglary, marijuana possession, or marijuana dealing. You can contrast that to the rational criminal model that you would expect a more uniform increase in all types of crimes if it was just criminals responding to, for example, changes in police effort. But you might expect that if the heat is impacting is acting through the psychological mechanism. It may also be changing police behavior. So in addition to making criminal defendants more aggressive, it may also be making police more aggressive. And as a consequence of that, police may be more likely to arrest individuals, which would manifest as an increase in arrests, exactly like what we see. So to test that hypothesis, we're going to compare the change in reported crimes to the change in arrests within the jurisdiction of the Houston Police Department. And what we see is that reported crimes increase by about, on days above 100 degrees, about 5% more than arrests. And that remains true even after we pool arrests over the subsequent 3 days. So we think that this indicates that police are not really changing their behavior in response to the higher temperature, that what is driving our result truly is an increase in violent and aggressive behavior that's leading to more violent crimes. This certainly doesn't rule out the possibility that there are changes in police behavior in hotter temperatures, but that doesn't appear to be what's driving our primary results. I want to turn now to how income and building quality can mitigate the impacts of heat. And to do that, we're going to examine the differential impact of heat on criminal activity in low-income neighborhoods with old housing stock, high-income neighborhoods with old housing stock, and then compare that to the impact in low-income neighborhoods with new housing stock and high-income neighborhoods with new housing stock. And so the older housing, we're going to showing the impact in these darker lines, and the newer housing, the impact is shown in the light blue lines, and it should be quite obvious that the difference between the old and new housing stock is substantially greater than the difference between the low or high income neighborhoods in either category of housing stock. And so we think that this is indicating housing stock matters more than income in protecting individuals from the negative consequences of heat. This makes sense. We know from other work, for example, on mortality, how important the advent of air conditioning was in reducing the impact of heat on mortality. And there's a very strong relationship in our data between the age of housing and the penetration of central air conditioning. So houses in the oldest housing category in our data have about 12 to 15 percentage points, or are 12 to 15 percentage points less likely to have central air than houses in the newest housing bin. So I'll turn now to the impact on prosecutors and judges. When we look at how heat changes prosecutor decisions, we don't really see any impact at all. But what I'm showing you in this table is the impact on judges who appear to be both more punitive and less likely to dismiss cases. So we see a decline in the percent of cases that are dismissed by judges when they make a decision on a hotter day. I want to emphasize that this is looking at the temperature on the day that the judge decides, as opposed to the temperature on the day that the individual was arrested. So when the judge decides on a hotter day, they're less likely to dismiss cases. They issue longer prison sentences, about 6.5% more time in prison for defendants who are sentenced on hotter days compared to those who are sentenced on cooler days. And the fines that the judges issue are also larger, about 4% larger on hotter days. Contrast that to no effect. We don't find any effect here on convictions. We think that is a result of the fact that judges have discretion over whether cases are dismissed. They also have basically sole discretion over the length of punishments. They do not have sole discretion over whether an individual is convicted. That depends often in criminal cases on the outcome of a jury deliberation. That difference broadly, I think, explains why we don't see effects on prosecutors but we do see effects on judges. Prosecutors tend to make their decisions in groups. So most prosecutor offices, when analyzing a case, will have junior staff or junior prosecutors review the case and make recommendations to a more senior prosecutor, who then reviews those recommendations and decides how to proceed. That process means that the decision about what to do in an individual case is spread out across several individuals and may be spread out across multiple days, which mitigates the impact of heat on any given day on any given individual. Judges, on the other hand, make decisions individually and often under substantial time pressure. Many criminal judges have their case counts reviewed and face sanction if they don't move through enough cases quickly enough. And so judges, in contrast to prosecutors, are making decisions by themselves under substantial time pressure. And we believe that that's where the impact of heat, that's what allows the impact of heat to manifest in the judge decisions as compared to the prosecutor decisions. To summarize, we find that heat increases the number of crimes committed, it increases arrests for these crimes, and conditional on being convicted, it results in longer prison sentences for those convicted of crimes. We'll turn now to this question of climate change and adaptation. And to examine this, we're going to do several projection exercises. First, we'll take climate projection data from multiple global circulation models for each of the IPCC's representative concentration pathway scenarios. So we do 2.6, 6.0, and 8.5 in the paper. I'm going to talk about the results from the 6.0 scenario here today. Depending on which RCP scenario we're examining, we have output from between 28 and 44 global circulation models that tells us the number of days in each of our temperature bin in each county in Texas every year from 2025 to 2050. We're going to take these numbers from every single one of the global circulation models and then take the average for every county in Texas across those global circulation models so that we end up with a count of the number of days in each temperature bin for every county for every year from 2025 to 2050. We'll then pair that with our measures of adaptation, which we calculate by taking the income growth and housing stock turnover in the block groups in our sample, which is basically all of the block groups in Texas. And we project those growth rates forward in time to see how income and housing, the age of the housing stock will evolve over time from 2025 to 2050 individually for every block group in the sample. That allows us to walk each block group through one of 4 income quartiles and one of 3 housing age terciles. And based on which income quartile or housing tercile the block group is in any given year, we assign it a level of adaptation. Using that level of adaptation combined with the projections of the temperature change, we assess the change in criminal activity in that block group relative to today. Unsurprisingly, what we find is that temperatures in Texas are going to get hotter. By 2050, there's about 15 more days above 70 degrees relative to today. But the number of cool days also declines significantly. By 2050, there's about 12 to 15 fewer days below 60 degrees relative to today. And that's important because as I mentioned, unfortunately, you couldn't see the figure, but as I mentioned on the violent crime graph, days below 60 degrees reduce violent crime relative to days between 60 and 70 degrees. So even if hot temperatures didn't increase at all, this decline in cooler days would suggest an increase in violent crime in the future as a result of climate change. And that's exactly what we see. In the base case, without any adaptation, in 2050, we see a 12% increase in violent crime relative to today. Now, adaptation can mitigate some of those effects when we include the full adaptation scenario, so that accounts for changes in income and changes in housing stock. We see about a 25% decline in that effect. So it's a 9% increase in violent crime relative to today's levels. But note that adaptation is not eliminating these effects even out to 2050. Now, this is based off of how we're projecting adaptation into the future. If you think income growth will be faster than it has been over the last 10 years, or that housing stock will turn over faster than it has over the last 10 years, the impact of adaptation would be larger. Conversely, if you think those things will grow more slowly, then the impact of adaptation is going to be less than a 25% reduction. But the other thing we do is look at the distributional consequences of this adaptation. And what we find is substantial inequality in adaptation. So today, Black and Hispanic households in Texas have substantially lower average incomes than white households. They also live in older housing on average. And their incomes are growing more slowly, and their housing stock is turning over more slowly than for white households on average. All of those things combined to mean that climate change driven increases in crime are going to be 21 to 25% larger for Hispanic and Black Texans than white Texans by 2025. Looking across race and ethnicity, these future impacts are going to be 70% larger for the poorest Texans relative to the richest. I want to underscore here that this is driven by changes in adaptive capacity. It is not driven by differences in future exposure or in the marginal impact of heat on these different racial or ethnic groups. What that means is we find basically the same exposure to hot temperatures in the future for Black, Hispanic, and white Texans. And when we look today at the impact of hot temperatures on criminal activity by race or ethnicity, we find essentially no difference in the marginal impact. That is, heat has a day above 90 degrees has basically the same impact on criminal activity in a Black majority Black group as in a white majority Black group today. So the differences that we're estimating in the future seem to be driven almost entirely by differences in adaptive capacity as opposed to differences in exposure to temperature or different marginal effects of that temperature exposure. So to summarize, what we find is that heat increases crime, especially violent crime. We think that that points very strongly towards a psychological channel through which heat is having this effect. But it does appear that those working in teams, so police officers often work in pairs, prosecutors, as I said, tend to work in teams together, juries, there's a group of them, see smaller effects on their behavior as compared to those who are going to be operating alone, citizens or judges, or under time pressure. We do see mitigating impacts from higher income and newer building, both individually, but then also jointly, especially newer buildings seem to really mitigate the impacts of heat. And we think that that's driven by higher penetration of air conditioning in these newer buildings. And adaptation does seem likely to mitigate some of these effects, although it will not completely eliminate them. And adaptation itself, or inequality in adaptation, may introduce substantial distributional concerns that we think policymakers should be attuned to and particularly focused on addressing to ensure that adaptation evolves in a way that reduces the gap, reduces the inequality in the outcomes from exposure to climate change rather than exacerbating them. So I'm happy, I think I'll end there and happy to take questions. If I'm a little bit early, we can just have more questions.
Thanks, Patrick. That was like right on time. It's a very interesting set of studies. I think what's remarkable is the granularity of the data you have to translate like every single step of the process in the conviction, in the arrests, and how that each of those individual processes are affected by heat. So I think what we're going to do is, let me see if there's any questions in the chat window. I don't see any, so I think we'll just collect the questions at the end and have that discussion. So on that note, let me introduce Nick. I think Nick is going next. Nick is going to present on the constitutional questions that are raised by climate change, particularly thinking about heat and violence in a slightly different context, which is where there isn't a lot of scope for mitigation and behavior seems quite constrained. So Nick, the floor is yours, and you have 20 minutes.
Great, thanks very much. Thanks everybody for joining us today. I want to take this minute to recognize Anita Mukherjee, who is my co-author on this paper. She does phenomenal crime research and has a lot of really other interesting projects that also deal with sort of the constitutional questions of how prisons work. So if you're interested in this kind of research, I strongly suggest you check out the kind of stuff that she does. Today, I'm going to be very specifically talking about how this relates to the question of how we treat prisoners and the consequences of those actions in the framework of being trapped and unable to adjust to climate change. So you should kind of think about this paper as a companion to the one that we just saw, which showed us the situation where we can think about how adaptation will play a role in how the world may or may not deal with changes in temperature. Well, we're going to be looking at a population that largely doesn't have any adaptive possibilities right now, and what consequences that has, both for them and sort of in a bigger picture context. So I can save myself some time here because Patrick laid out a great example of all of the research that's already been done on the question of heat and violent conflict. There's a lot of stuff that's in medical fields, sociology, psychology, economics, and all of it seems to suggest that there's a link between heat and violence and heat and conflict, which of course is a super pertinent question when we're talking about the fact that climate change seems to be pushing us in a direction where we have rising average temperatures. Now, a lot of these studies tend to be on big, large scale pictures from the state of how often do civil wars happen in countries, how frequently do we see riots, and also really individualized actions down to the point of what Patrick was showing us, where we could observe individual crime, whether or not people engage in criminal behavior on a particular day, even some studies that were done sort of randomized control trials where they adjust the temperature of a room and then ask people questions to see if they behave more or less destructively. And all of the research tends to line up with the idea that more heat means more conflict. The challenge here is that it's hard to separate the effects of heat itself from all the other things that tend to go along with heat. So for example, if we're thinking about situations where we're talking about civil wars, well, that might be that there's heat, and because there's an increase in heat, there's drought, and because there's drought, there's impacts on agricultural productivity, which changes income, and income has effects on violence. We can also think about the fact that on hot days, people might be more or less likely to be outside, which makes both an increased possibility for criminals to find people for crimes and also an increased probability of being spotted as a criminal. Patrick talked a lot about altered police activity. All of these things kind of go hand in hand with changes in temperature. And oftentimes, we can't observe the amount of mitigation in which people engage. So while we can talk about the existence of mitigation, and we know that AC is out there, we can't see whether or not people spend the day inside and run their air conditioners. And we also can't see if people drastically alter what would have been their normal daily routine in response to the higher temperatures. And those are both costs we have to think about. Running the AC is costly, both in terms of right now, higher electricity bills, and also in terms of potential increase in climate problems. And even something like staying inside today or altering my plan to go jogging are costs that we incur as a result of higher temperatures. So we're going to take our study, which is an area on heat and violence and the relationship it has in correctional facilities in Mississippi, as a way to answer two sort of small picture and big picture questions. The small picture is going to be, how does this impact behavior in prison, and what are the consequences of that for that community? And the big picture story is going to be, how do we think about this when we're in a world where adaptation and mitigation are largely constrained? So why do we want to think about prisons just in their own right? Prison conditions impact about 2.5 million people in the United States. That's largely because of 2.2 million inmates and a number of people who are working in those conditions as well. And prison violence is a prevalent and growing problem. So data suggests that around 21% of male inmates are assaulted in the first in a 6-month period. And this is also a key concern for guards and prison staff in terms of daily safety. And of course, all these actions lead to large social costs, death of inmates, death of workers, injury, trauma, and can also play out in longer sentences and prisoners being denied parole, which has other costs in terms of keeping people in prison for longer, increases in recidivism, and those kinds of social issues. So this is a pretty expensive thing to worry about in terms of both safety and actual keeping people in place and the costs associated with keeping people in prisons. Now, the Eighth Amendment very specifically bans cruel and unusual punishment, and that's been the backdrop to a large number of lawsuits on exactly this idea. Air conditioning is largely prevalent in most of the housing stock in the South, but rarely in prisons. In fact, in the data we're going to be using to talk about our situation today, none of the prisons we analyzed had air conditioning available for the incarcerated individuals. So one of the arguments is often that this is incredibly expensive to do. The cost of installation is really high because some of the prison structure is quite old, and that means it's not really a matter of putting in a window unit. We're talking about multiple millions of dollars of expenditure. And it's also made, the argument rather, is also made that maybe it's just a matter of, well, they're in prison. Prison is supposed to be a very uncomfortable situation. It's not supposed to be nice. So it's probably the right thing to do to not give them these creature comforts because frankly, there are people in the South who don't have the income to afford them in the first place. So is it fair to give them to prisoners when we don't provide them to the average person? And this leads to a really politicized argument about temperature controls and prisons and whether or not there appears to be an issue of being tough on crime. And we know it's not just about costs because there are situations where states have spent more money fighting the lawsuits than the anticipated cost of actually installing the air conditioning itself. So we have this example here where Louisiana spent about $1 million fighting AC installation in its prisons, which was anticipated to cost $250,000. So this isn't just a pure cost argument. This is also, well, maybe this is just how it needs to be argument. There have been courts across various states, Wisconsin, Arizona, and Mississippi, that have all ruled that incarceration in extremely hot or cold temperatures violates the Eighth Amendment, but there haven't been direct actions taken yet to enforce or implement the installation of air conditioning in these environments. And there are no federal laws mandating temperature controls or prisons or jails. So this is still largely up to the people who are actually in charge of the prison. And that means at a state-by-state level, we have a lot of variation in terms of what's going on. I have some anecdotes here from a couple of articles that I've got cited at the bottom for people who were in the prison environment and wanted to talk about these extreme conditions. Someone was saying it's so, oh, I appear to have lost my slides. This is problematic. And they're back. Okay. So people were saying, it's so hot in here, I put my hand to the wall and it would get burned. My cellmate and me would take turns sleeping on the floor. You clean the floor, throw water down on it so it was like a puddle, and lie down on a sheet. And in some facilities, inmates residing in given cell blocks are given ice water to pass down the row of cells, which often leads to violence and hoarding of the vital resource. And this is all made worse by the fact that a lot of the prisons that are currently in operation are facing overcrowding issues, an aging infrastructure, and inmates who have health conditions that are exacerbated by heat. Oh, lost my ability to advance my slides as well. Now, thinking about sort of a bigger picture story instead of about the specific prison story, prisons serve as a rare situation where we have good daily data, where we can observe what happens, and effectively no mitigation or avoidance. Which is to say, since these prisons have no air conditioning, we don't have to ask the question of, well, is this the true effect, or is this the effect after people use their AC? And because avoidance is not really a thing, prisoners can't go to a different location when it's a pretty hot day, and they can't just change their daily routine very much. We also have something that is avoiding that measurement problem of whether or not this is what people would do if they wanted to versus how they change their behavior that day. And while the makeup of prisons may not mimic the makeup of the general population, the situation in which they find themselves is similar to many of those living in poverty across the world. Lack of air conditioning or unstable grids to be able to handle the load of air conditioning, and constrained mobility either by direct regulation or by lower income, which prevents the kind of moving around that we think people might do when they're facing extreme temperatures. And so what we're going to be talking about here is effects that are closer to the raw effects of heat on violence and may more accurately describe the effects of heat in a lot of parts of the world that don't have the adaptive capacity that Patrick illustrated can help make a big difference when we're talking about the impacts of heat on violence. So for the data, we're going to be using some data on the prisoners in Mississippi. We look at daily infractions, which is to say the write-ups that guards do of people's behavior on a daily basis. And because we have stuff on a daily basis, we're able to go through and adjust for things like seasonality and general trends and all of that kind of background stuff that you might be worried about that changes both with violence and temperature. So for example, if you think people are more violent in summer for reasons other than related to it's hotter in the summer, we're going to be able to adjust for that because of the data that we have. And given the prior work on temperature, we're going to do the same kind of thing that we just saw, where we're not going to use a linear effect of temperature, but whether we're going to break it down bin by bin and ask ourselves, how does temperature change behavior when we deviate from the range that the science suggests is the optimal range for humans? So all the things that we've done on research on temperature and blank outcomes suggest that humans are happiest when we're around 60 to 69 degrees Fahrenheit for an average daily temperature. So we're going to ask ourselves, well, what happens if we take a day from that bin that seems to make people the most comfortable and push it into a temperature range that is higher or lower than what we would consider to be optimal for the human body? And what we're going to show you is that the majority of the effects that we see pop up on days that have an average temperature that is above 80 degrees Fahrenheit. Now, it's worth noting what that looks like and how many days we might see on a place like the state of Mississippi. So I've got a picture for you here of the state of Mississippi where we've highlighted all of the counties that have jails or prisons that are within our data. We've got 36 facilities that are located across 29 different counties. Some of those are sister facilities that are right next to each other. Some of those are a single location, and that's marked by the different shapes there. And the gradation of the red here is meant to illustrate how often that county or that area sees a temperature range that is above 80 degrees Fahrenheit on average. And you can see that across the state, both east and west and north and south, we have pretty good variation in terms of how frequently we see these kinds of days. But even in the coldest areas, we're still talking about Mississippi, and that means around 10% of days fall in an average 80 degree or higher range. In the hotter areas, down in the south and toward the west, we see that that gets up to almost a quarter of the days in the year fall into this particular category. So the takeaway here is that we've got variation geographically as well as across time of year, and that's going to help us to identify these effects rather than just summer versus not summer. It might be worth thinking what an 80-degree day means, because you might be thinking, well, wait a minute, 80 degrees isn't that bad. In fact, that sounds quite pleasant. It's important to remember that that's the average temperature. So we're talking about 80-degree average for the day, which is average across both day and night. So on the left side of your screen here, the blue that you're seeing is the daily minimum for days that had an 80-degree average, and the red distribution is the daily maximum for the days that had an 80-degree average. Now, what I want to focus on here is the daily maximum, which is to say the majority of the days that fall in an 80-degree average range are hitting maximums that exceed 90 or 100 degrees. And even without humidity, that's really hot. But it's also worth remembering that Mississippi is a very humid place, which means that the heat index is actually much warmer than the temperature would tell you. In other words, what it feels like to the human body is much higher than what the temperature actually reads. On the graph on the right, what I've plotted for you is the average daily temperature on the x-axis and the estimated maximum heat index on the y-axis. And what we want to show you here is for all of these days that are 80-degree plus on average, they have highest heat indexes that range from 85 or so all the way up to 120 plus. In other words, at the hottest part of the day, it feels like it's reaching 120 plus degrees. And this is outdoor measurements, and they've done research to actually check how this feels indoors and have found heat index temperatures in excess of 150 degrees Fahrenheit. So on hot days, we're talking about really, really hot conditions that are happening inside these correctional facilities. So what does our graph look like here? First of all, I want to give you a basic idea of how often these violent incidents are happening, because we're not talking about a gentle shoving. We're talking about violence that falls in the category of assault or higher, which includes actual physical harm and death. And the mean of that is about 0.1 incidents per facility day, which is kind of a weird way to think about it. So I'll just simplify that down to the average facility has around 36 of these incidents a year. And what we find is if we take a day from the optimal range, which is our 60 to 69 degree Fahrenheit, and bump it instead into the 70 to 79 degree Fahrenheit range, we see that there's a small increase in behavior, in violent behavior. In fact, a relatively small uptick compared to, sorry about that, the range that we see on this upper end, which is the 80 degree plus. Well, what is that dot telling you? That dot is telling you that if we have a day that was 60 to 69 degrees Fahrenheit and instead make it 80 plus Fahrenheit, we see about 0.03 more incidents per facility day year, which boils down to almost around a 25% increase. And if we do it by prisoner, as opposed to for overall population, maybe you're worried some prisons are small, some prisons are big, it works out to about the same. About a 0.04 increase per 1,000 prisoners, or about a 21% increase in the daily number of events. We also see an increase in the probability of any violence that day. So we reran the estimation, but now instead of asking how many violent incidents happened on a given day, we ask, what's the probability any violent incident happens on that day? And that's a baseline of about 5%, which is equivalent to saying on any given facility day, on average in our data, there's a 5% chance that there ends up being a violent act in that prison. And we find that when we transition to this upper range again, we're looking at a 1.2 percentage point increase in the probability of a violent incident, which compared to the average translates to about a 24% increase. So right around the same thing that we saw in terms of absolute counts. We thought about what mechanisms might be driving this, and oftentimes we get the question of, well, is it because heat makes it difficult to sleep, or because heat throws off your routine? And it's not the heat itself that's causing the problem, it's all those other things that are causing the problem. So one of the ways we tried to get at this was by looking at the effect of heat in prior days on today's behavior. If it's about sleep, for example, then really hot days, the last few days might make you sleep deprived. Now you're more agitated and there's an increase in violence. But what we found is if we look at the indicators for it was a really hot day yesterday, the day before, or the day before, and try and adjust for all of that at the same time, what we find is none of that really has any impact on today's temperature. So it doesn't seem to be a buildup effect that we're seeing within our data, but rather sort of the impact of today's temperature on today's behavior. Some of the other mechanisms we thought about, well, maybe this is just about throwing off my game, and so it's not actually about violence. It's just about everything in general kind of goes worse for us those days. It could be that guards are in worse moods, and because guards are in worse moods, they're more likely to write people up for anything. All those things could be going on here. So we decided, well, what if we looked at things that were not violent crimes, but any other kinds of write-ups, which was similar to what Patrick was talking about in his earlier presentation. And similar to what he found, we also find that the effects for non-violent factors are muted or zero. So we've got here a graph of the same general idea. What's the impact of taking a temperature day and putting it hotter or colder than the ideal range for humans? And for aggressive behavior, which is things like just basic shoving or verbal altercations, refusing to work, demonstrations, or disobedience, these are all relatively small scale incidents. We don't see the same kinds of effects going on here. And so it seems to suggest, in alignment with what you saw in the last talk, that violence and heat have a particular relationship. It's not just violence and heat and disobedience. It's not just heat and disagreements. It's heat and specifically violent behavior. So how do we want to think about these results? This is one more piece of evidence in the contribution that higher temperatures contribute to violence. The more evidence we have on something, the more confident we are we're nailing down the right thing that's going on there. We have a scenario with fewer avoidance or mitigation or reporting issues than you find in a lot of other data. So we have a unique ability to speak to the raw effect of heat on violence. And climate change means this problem is likely to spread and intensify, not just in a general sense, but even in a specific prison sense, as a lot of the prison infrastructure is not prepared for higher temperatures, especially when we're talking about places that have traditionally had colder summers, like the Northeast and the Midwest. Now, for specific prison policy implications, it looks like withholding temperature control is increasing incidence of prison violence, which has some really important downstream complications and consequences when we're talking about the goal of reducing costs of incarcerating individuals. Not only do we have the problem of injury or death, we couldn't observe this directly, but we know from news stories this has been a problem, but this also leads to write-ups, which lead to denied parole, which lead to new crimes, which leads to extended prison sentences, and that means increased incarceration costs. So if the goal is, well, we can't install AC because it costs too much, on the other side, we have to consider if lack of temperature controls is resulting in additional violence, and additional violence is resulting in longer prison sentences, then we have another cost of not doing something as well. We think these are really important considerations when we're trying to figure out the true costs of omitting temperature controls and how we think about what temperature in prisons does to both behavior and the consequences of incarceration. So that's what I've got for you. Thanks very much, and I yield back to T-Rock.
Thanks, Nick. That was really informative. Has my audio stopped working? Okay. Can everyone hear me? No. Okay.
Yeah, I hear you fine.
Okay. For some reason, the chat is telling me that my audio has stopped working, so it has really not. Okay, so thanks a lot. That was really fascinating because I think it speaks to this like broader issue of how we have built up so many institutions and norms in society, and how many of these, in ways that we had not thought about, are going to be challenged on increasingly warmer climate. We do have a few questions for you, Nick. From starting with Colleen and Claire and Dylan. If you can give like brief responses to these right now, that'd be great, and then we can continue on with the presentation and then take a larger conversation at the end.
Yeah, so it looks like for Colleen, it seems like the question here is about how we link the issue of adaptation to climate questions and the goal of distributing the impacts toward prison and disrupting rather the movement toward prison in the first place, which is to say, I think, can I say anything about the process of getting stuck in the prisons and how that relates to climate change? That's something that I think our first presentation is a great example of, because while Patrick only had 20 minutes to talk to you about it, the paper goes much deeper in talking about all the different ways in the criminal justice system that heat has impacts on our long-term outcomes. And that's probably a question best aimed at him because of that. So I'm going to punt on that one because I can only speak directly to the prison situation we've got here. To that extent, Claire's question on what's going on with the really wide confidence interval below 30 degrees Fahrenheit, which I think is hanging out in this range over here, you're spot on, which is to say we have a super small sample size. There aren't that many days in Mississippi that have an average temperature of below 30 degrees Fahrenheit. I actually went through the data and checked this, and it happens super duper rarely. So we don't want to be putting any weight on that super low estimate there because we don't think we can say too much about it. This is actually one of the things that I thought was really cool about the differences we saw between our study and Patrick's earlier study, which is there we did see changes in the lower temperature ranges, and here we don't seem to. Now, I don't know if that's a function of the kinds of temperatures we have, though Texas also probably has very few cool days, or if it's a matter of the kinds of population and situations we're talking about here, where cold temperatures mean something different in prisons than they do in sort of the general population. Dylan's question on do we have prison health records available? Boy, do I wish we could match all this. We're working on it. The prison system of Mississippi has been very generous in sharing data with us. But as you can imagine, the current condition in terms of COVID and data acquisition has been made much more complicated. So we're working on trying to find good records to actually be able to link these things to the questions of, did this result in a physical harm? Did this result in physical death? We can't know that. What we can see is the write-up and whether it's described as murder, which we take as indication of death, or whether it's described as violent aggravated assault or something like that. And then Claire's final question on we should also have fewer prisons. That would help with the cost of air conditioning. Fair point. If we're talking about what we have to do to fix the problem, the fewer prisons we have, the fewer prisons we have to replace. That is a very different question that is probably best left to my co-author, who, as I mentioned, has done a ton of work on the issue of prisons and recidivism and social welfare. But what I will end with saying is this does say something about where we should expect to see the most problems in terms of the future. Because the South, even though it has hotter days, you might think it's going to be worse there on average, because the South is traditionally hot, infrastructure has largely been built to handle hot days. So even prisons in the South are generally constructed to be of the kind of building that won't necessarily be problematic in the hottest of days, or less problematic rather. That's not going to be the case in the Northeast, where buildings have been kept usually designed to retain heat as opposed to let heat out. So where prisons are located is going to be a really important question when we're talking about how climate is going to change the situation for prisoners specifically.
Thanks, Nick.
Thank you.
On that note, our last presentation will be by Dylan Brewer, who's an assistant professor at the Georgia Institute of Technology, and he'll be talking to us about extreme weather events, emergency requests, and what we can learn from newer high-frequency data. So Dylan, the floor is all yours. You have 20 minutes.
All right, great. It's looking like my camera is giving me some issues here. I'm just going to refresh and I'll be right back in. Okay, great. All right. Can everyone hear me now? Okay, great. Awesome. Thank you so much. This was really great to be able to see Nick and Patrick's talks. I have an early stage paper that is looking at domestic violence and temperature. And so it was good to get a little head start there. Okay, but today I'm going to actually cool us off. I'm excited to be part of this session on heat and be able to bring you some evidence about extreme cold. So our paper is called Do People, cannot advance the slides now. Do people listen when it matters? Evidence from smart thermostat data on compliance with governmental emergency requests. And it is joint with my co-author, who's also at Georgia Tech, Jim Crozier. All right, so beginning on January 29th, 2019, temperatures in the Midwest declined to nearly record low levels as cold air in the stratosphere over the Arctic, blew southward over North America. So low temperatures were seen in cities across the Midwest, reaching -23 in Chicago, -13 in Detroit, and -11 in Indianapolis. And these are all in Fahrenheit, by the way. And the lowest recorded temperature was -45 degrees Fahrenheit in the US. Then on January 30th, you can see here that the high in Detroit was -2 degrees Fahrenheit. There was an unexpected supply side problem. At 10:30 a.m., so that's where the arrow popped up there, a fire broke out at a natural gas compressor station in Macomb County, Michigan. This is a picture that somebody took just outside of their house of the fire, so it was pretty large and probably quite scary for them. So what we have here is we have on one of the coldest days that has ever been observed, a fire at a natural gas facility. January 30th was a record-setting demand day for natural gas, and what this fire did was it actually created an acute shortage of natural gas. At about 2:30 p.m., the utility, one of the two major utilities in Michigan, consumers realized the grid was unstable, the natural gas pipeline grid. And so they tweeted a request to consumers to voluntarily reduce natural gas usage. And they also broadcast on Facebook Live a sort of desperate request to reduce thermostats to 65 degrees Fahrenheit. And so you can see she doesn't look very happy. So how bad was this? What could go wrong? If demand was to exceed supply at this time, then there would be a total system failure, which would result in people not being able to heat and temperatures being below zero. So this is very similar to what happened in Texas earlier this year. But 75% of people in Michigan heat using natural gas, and the temperatures were below zero. So it could have been much, much worse. So as the fire raged on, there was no, looks like I froze there a little bit. That's okay. As the fire raged on, we basically, as the fire raged on, the scenario was getting worse. And so the Consumers Energy actually requested that the governor of Michigan release an emergency request for individuals to reduce their thermostat settings. So you can see here at 10:01 p.m. that Governor Gretchen Whitmer from Michigan tweeted a request for everyone to reduce their thermostats to 65 degrees or less until Friday at noon. And at 10:30 p.m., an emergency text message alert was sent to everybody in the lower peninsula of Michigan, requesting people to reduce their thermostats to 65 degrees or less. So what am I going to do in this paper? In this paper, I'm going to use smart thermostat data from Ecobee to study how households responded to the emergency request for reductions in the use of natural gas for space heating. We're interested in whether people listened when it really mattered during this crisis. We want to find out who listened, and we want to see what we can learn that can help us manage future emergencies. How is this related to a warming climate? That is a good question. There are actually debates in the climate literature about these polar vortex events that have seemed to be more common in recent years. But there is a theory that melting sea ice can create feedbacks that basically disturb the polar vortex, causing it to dip down to North America and Northern Europe. So it's a debated question in the literature, but it is believed that possibly climate change is causing these polar vortex events to become more common. Even if that's not true, it's relevant to the questions that we're going to answer are relevant to a broad set of climate emergencies. You can imagine hot days where electricity demand is extremely high and a similar emergency event occurring. Okay, so the data that we have are smart thermostat data from Ecobee. These are 5-minute interval data that we have aggregated to the hour. We've done it at finer intervals, but we haven't seen any change in our estimates. So we're sticking with the hour aggregation. We have information on households' thermostat settings, their outdoor temperature, and their humidity, and we know what city they're located in. We have a limited amount of information about the home and the number of occupants. Our empirical strategy is going to be to use the surrounding states, the Great Lakes states, as controls for Michigan, the treatment state. So we have households in Wisconsin, Illinois, Indiana, and Ohio, and those are going to be used as controls for treatment households in Michigan. We have data from January 1st through February 7th. There are 2,700 Michigan households hourly data. That gives us 2.3 million observations. And we have 7,900 control households, and that gives us 7 million observations from the controls. And this is sort of what the event looks like when you plot the average thermostat settings for Michigan households and for control households. So you can see that we have nice parallel trends. The controls are good controls. They're very comparable to the households in Michigan. And you can see that when the first alert was made, that it took a little bit of time for thermostat settings to go down. And then at about 10 p.m., the gap starts to widen. So that's when the governor makes her request. So we find that the average household in Michigan reduced the thermostat by 0.8 degrees Fahrenheit. We also look at the level of compliance with the order. So even though households could reduce their thermostats, we wanted to know whether households complied with the letter of the request. So this is plotting the fraction of treatment and control thermostat settings that are actually less than 65 degrees Fahrenheit. So the same sort of picture, but you can see that that in Michigan, only 50 households at the peak actually had their thermostat settings below 65 degrees Fahrenheit, relative to 30% in the control. And actually, our estimated additional treatment effect is going to be about a 20% at maximum. On average, the average effect is actually going to be an 11% compliance rate. So sometimes I see this 11% number and I think it's small. Other times I think it's pretty big, but it's kind of it's debatable. Okay, so what does this mean in terms of energy use? So we don't have natural gas consumption data. That's kind of the biggest limitations of the paper right now. But we do get to observe how many minutes the furnace fan was running during the last hour. So we can go ahead and plot these, and you can basically see that it's kind of hard visually to detect any effect on the amount of time that the furnace was running. So the way that furnaces work is that a normal furnace basically runs at one intensity, runs at full speed, or it's off. And so when the temperature drops below the thermostat setting, the furnace will run until the house is warmed up to a certain point. And so if the furnace is not running, if the furnace fan is not running, then the furnace is not burning natural gas. So this is going to be our proxy for natural gas savings. So we do find that there's about a 5.6% decrease in the time that the furnace fan runs, and that is only a decrease in 1.5 minutes per hour on average. But 5.6% is actually quite a large effect in the energy literature. So similar programs that do things like compare your consumption of water or energy to neighbors' consumption can get about a 5% treatment effect. Actually, increasing prices of energy can usually result in a 10% or more treatment effect, depending on how those are done. So 5.6% decline in energy use in this setting is actually quite good. So we take this as we really see this as being an effective intervention. You have that 0.8 degree Fahrenheit reduction, 11% compliance, and a 5.6% reduction in how much the furnace was running. So I do think that is quite a good result, how thrown together this response was at the last minute. So ultimately, what happened? Ultimately, the system stability was restored, and an all clear was declared at midnight on the 30th. So what else can we learn from this? So what we're doing right now in the paper is we want to know who complied with the order and who defied the order. So what we've seen during COVID-19 is a series of similar requests for voluntary compliance with different behaviors that make us safer. And we see that there's been a politicization of the emergency response that has led to some people complying and other people actively defying. So we were curious to see whether any of that was going on here. After all, the request did come from the governor. The sort of most broadcasted request did come from the governor, who was actually elected just 3 months prior to the emergency. And she is a Democratic governor. She's kind of actually become famous since then because of some of her policies related to COVID-19. Right. So she actually she received 53.3% of the votes. And so what we're going to do is we're going to see how compliance with the request was related to the vote share that she received in the counties that the households are located in. Okay, so we have data from the CQ Press. Again, these are actually vote shares. It's the vote share of her election campaign. Okay, so now what we've done is we have estimated the effect of the order by the vote share interval. And what you can see here is that in the counties where the governor had the least amount of support, so on the far left, the effect was the smallest. But surprisingly, we don't see that more support for the governor means more compliance. So surprisingly, the most Democratic-leaning counties were not the sort of most responsive to her request. So we take this as evidence potentially of defiance, but not necessarily of additional compliance with the request based on political affiliation. We do this again, just looking at the fraction of households that have a thermostat setting below that 65-degree threshold. And we see the same thing, that the compliance rate is the lowest in counties where Governor Whitmer received the least amount of support. So what conclusions can we draw from this research? So we think that voluntary requests can be effective, but what we've seen from the data is that they require time and they require a large platform for the announcement. Before the governor's request, there was only 5% of households that had their thermostat settings below 65 degrees. And after she sent the alert via the text messages, that number jumped to 20%. We also see, and these results are brand new, they didn't make it into the slides, but we have also seen that there are strong anchoring effects. So they chose the 65-degree Fahrenheit threshold to ask people to reduce their thermostats to. And what I have, work that I have done in the last week has shown that people who typically have their thermostat settings below 65 were completely unresponsive to this emergency request. Interestingly, also, people who typically have their thermostat settings above 75 degrees or above also were much less likely to comply with the request. So those people were discouraged by this target goal of 65 degrees Fahrenheit. So we think that these anchoring effects are big, and really what needs to happen is utilities and balancing authorities need to sort of practice and have these policies fine-tuned before they go ahead and make that ask. The other result that we think is really important is that political polarization seems to be reducing the effectiveness of governments during a crisis. And what we think is that emergency demand response processes should be formalized and tested prior to emergencies like Michigan and Texas to have the best effect. And that's it. Thank you so much.
Thank you, Dylan. That was a fantastic study. I think the implications, of course, for energy use are great, but just thinking beyond a whole host of crises that we will have to undertake as climate change makes its way through the United States and what political polarization actually means for the ability of governments to be able to say something in response. I'm seeing that there are 2 questions in the chat window. Do you want to take those before we open up the floor to everybody else? And I don't think we can see you, but that's maybe fine for now. And then after you're done with the Q&A, maybe you can refresh your screen.
Sorry about that. It was working during the test, but that's okay. So does that mean that once all the ice is gone, we won't have to worry about polar vortexes? I am not a climate scientist, but I suspect that that would not be a good thing. Okay, and then in the compliance and defiance tests, can we control for information somehow? Is it possible that whether individuals heard about the request is correlated with vote share? Yeah, so I should emphasize, we do think that our mainline results about the effect are causal results, but we don't think that the compliance and defiance tests can be interpreted causally. So political affiliation is going to be related to a lot of things, like income. I have to admit that I didn't think that it could also be related to whether they heard about the request. That is completely true as well, though the alert at 10 o'clock did come across all cell phones in the state. So we think that there was essentially 100% penetration of the message. So I don't think that that is what's going on, but I do think that things like income could be playing a role. One thing that we have considered is we do have information on the fraction of people at home during this event. And so we are going to be working in the future on using cell phone location data to see the fraction of individuals at home who were able to. And that could end up being correlated with who was with vote share as well. So that could be an important control. But that's a good question, Patrick. Tivra, I don't think we can hear you.
Yeah, I was going to say, just to follow up on Patrick's question, can you take a look at the response, the spatially disaggregated responses on Twitter to the governor's tweet in response to this crisis? So, Patrick Bayless, Fran Moore, and a couple other people have done a really good job of being able to mine out and textualize what's in tweets. And I was wondering if you can get a better measure of the reaction that's coming from these tweets, so you can say something more than just about what's happening on the response side, but also what was the initial reaction on either side to be yes, we're going to do this, or no, we're not going to do it. And you could look at concentrations of what perhaps the very vocal response from the non-compliers might have been. It might be more of a lift than possible, but just a suggestion out there.
Yeah, Tivrat, that's really cool. I teach Patrick Bayless et al. In my graduate environmental economics class, and I did not think about bringing in tweets, but that could be quite interesting to see exactly what the sentiment was and seeing whether that is correlated with the amount of compliance. People were not happy. The tweet. So I have looked at the responses to those emergency requests, and people were certainly not happy. So that is definitely something we could do.
Yeah, and the other thing I was wondering was, so you've seen this about you say about 5% of the households were below 65, and then it went up to 20% and you see about the 6% reduction. Can you estimate what the equivalent, like, do you know what the price elasticity in this area would be? Like, what would be the equivalent amount of like price increase that would have triggered the same reduction in use? And that would just like it be a very effective benchmark at contextualizing the magnitude of what we're finding. Because clearly, like the utility has to have something at the back of their mind of how much energy reduction they needed. Right? I don't know where they came up with the 65 number, but presumably there was some calculation involved in where they figured that, okay, if like X percentage of people complied with this request, it would translate to a Y percentage reduction, and that'll be enough to get us in the safe harbor space.
Yeah, that's quite interesting. So I do think that I could actually use sort of like a commonly accepted elasticity for natural gas consumption, which is usually like 0.2 or 0.3, to see what the equivalent increase in price would have to be. My guess, and I actually have an appointment to speak with people at the utility coming up here, and I'm going to ask them how they came up with the number. My guess was that they scrambled and they thought that they wanted something concrete, so they picked 65. The only other consideration that is quite interesting here is that there is a too low level of the thermostat. So if you set your thermostat far below 65, you then become at risk for having the pipes freeze, and that also would be bad. So yeah, it's definitely really interesting.
Yeah, I do appreciate you explaining to me about the pipes freezing, seeing as I'm in San Diego at the moment. But I did spend a considerable amount of time in the Northeast, so I'm familiar with that. But anyway, so okay, that makes sense. Let's open up the floor to any questions. I think we've tackled most of them. Patrick, I think you had one or two questions, but I think you answered them in the chat. So let me just go ahead and see if there's any other questions. If somebody's typing up a question, just flag it to us. Otherwise, we'll move into the concluding part. Okay, so I think on that note, we will conclude this session. I want to thank Patrick, Nick, and Dylan for excellent presentations. I think we've learned a lot about, particularly in the first two presentations, about how the existing infrastructure that has been set up, the social infrastructure that has been set up in many parts of the United States, is not exactly built for the kind of climate change that we're going to be experiencing, and perhaps it is time to rethink some of these social institutions in the wake of climate change. Then Dylan's presentation on really trying to help us think through what it is that governments can do, how effective they are, and what are some of the factors, particularly social factors, that might constrain their ability to be effective as climate change makes its way through the United States. So thank you.
Tiva, can I interrupt? I got one question.
Oh, okay. Yeah, let's take that.
So someone asks, what are the adaptive efforts that can contribute to decreased violence as examined in relation to heat and conflict? So I think a major one is access to air conditioning. And as I noted in my answer to one of the other questions, that also often means improved grid reliability and access to electricity. You can't run your air conditioner if you don't have access to electricity. But I think we also, as I mentioned in the talk, we find that teamwork, working in conditions that are not putting you under time stress may help. And there's a whole section of the paper I didn't have time to talk about where we examine how access to weapons also impacts the proclivity to engage in violence. And we find, so Texas changed a law about halfway through our study period, and they made it a lot easier for people to carry guns around in public. And we see a substantial increase in crimes related to guns after the implementation of that law. There's another paper by Jed Dolyak and Jonathan Colmer that looks at the permissiveness of gun laws across states and finds in states with more permissive gun laws that there's a substantial increase in the relationship between heat and violence. So not just that there's more violence, but actually that a hot day in a state with a lax gun law leads to more violence than a hot day in a state without a lax gun law. So I think laws that reduce access to weapons is a major potential adaptation to this heat violence relationship.
Thank you, Patrick. Yeah, and I think this is, as we start to think about some of these answers beyond even the United States into even poorer settings, there's a whole active body of work on what the relationship is between poverty and and psychological mental health effects that are also correlated with violent and depressive behaviors, and thinking about both interpersonal and intrapersonal violence. So I think there is a suite of solutions that are available. And I think as researchers, we're just starting to scratch the surface on that. So thank you again, Patrick, Nick, Dylan, for very enlightening conversations, to UCLA and the Luskin Center for hosting the symposium, and to all their sponsors. Thank you, everybody.
Yeah, thank you very much, everyone.
Thanks, everyone.
Thank you.